51 points are inside a square of side length 1. Prove that we can cover some 3 of them by a circle with radius 1/7. Okay, so it might not be immediately obvious how we approach this problem because we've got a square, but how do we relate that to circles? And so what I'm going to do is I'm going to start by looking at things inside the square that are easier to work with. Namely, I'm going to make smaller squares instead of smaller circles. So I'm going to actually divide this into 25 1/5 by 1/5 squares because you see in the problem statement that 51 is pretty close to 50, and 50 is 2 times 25. So it would make sense to do something in terms of 25 because otherwise 51 wouldn't be an awfully convenient number, would it? Okay, so I'm going to claim that some three of them are inside one of these 25 squares. And I'm going to do that using Pigeonhole Principle, which is basically if you have n+1 pigeons, and you put them in n holes, there must be a hole with more than one pigeon. Right, and the reason this applies to this problem is because let's say you wanted to prove that this wasn't true. If you have 51 points, you can't put 3 points inside one of these. I mean, it's possible to put them inside the square such that each of these smaller squares has at most 2 of them. Well, the maximum number of points we could have is 2 per small square. And since there are 25 small squares, the maximum number of points you could have would be 50. So since you have 51 points, there must be at least 3 in one of these squares. But how is that going to help us? We're concerned about circles with radius 1/7, not squares with side length 1/5. But I'm going to claim that one of these small squares can fit entirely inside of a circle with radius 1/7. So you have this circle with radius 1/7 and this square with side length 1/5. And I'm going to claim that this square can fit perfectly inside this circle. And the reason is because, well, the farthest distance between 2 points on this square is a diagonal, right? Yeah. Since the side length is 1/5, this diagonal length is square root of 2/5. And what does it mean for this square to be able to fit inside the circle? It means that the diagonal must simply be less than a diameter of the circle because then we can actually fit it inside the circle. Like for example, if we lined up their centers with each other and this diagonal was less than the diameter, the square would fit entirely inside the circle. And the circle's diameter is, well, since its radius is 1/7, the diameter is 2/7. So if 2/7 is greater than root 2/5, then we're done because the square could fit entirely inside of the circle. So we want to show that 2/7 is greater than root 2/5. And this is true because if you square both sides, you're going to get 4/49 is greater than 2/25, which is true. If you need more convincing, you can cross multiply on both sides since everything's positive and you get 100 is greater than 98. This is a 4. 100 is greater than 98. And that is obviously true, which means that this initial statement 2/7 is greater than root 2/5 was true, and therefore this square can fit entirely inside of the circle. And since you must have 3 points inside one of these smaller squares, and the smaller square can fit entirely within the circle, you can cover the square with a circle and thus get the circle with 3 points inside of it. And therefore we are done. So thanks for watching and I will see you next time.